Anyway, be quiet. I'm glad we had this talk. Is what I'd be saying if I was glad we had this talk, which I'm not. Let's get to work. Okay, listen. I want to not, you don't have to write this, though you could. Let's not do this one just yet. Let's just do some good old-fashioned fraction adding, which you guys are very good at and never causes you stress and you never make errors with, right? You guys are famously very good at adding and subtracting fractions. So listen, what if we add, I don't know, 1/5 plus a half? All right, you can write this if you want, but you don't have to. Does that equal 2/7? No, right? Definitely does not. You can't just add numerators and add denominators. Again, we could go back. I don't want to do this more than once. But, this is the classic. Imagine we've got, a 5-slice pizza. 1, 2, 3, 4. 1, 2, 3, 4, 5. A perfectly fair 5-slice pizza. Let's try that again. I do not trust my ability to do this. That's, good. And that's like having 1/5 of it, right? And then we order a second pizza, and this time I'm going to take half of it, right? How much do I have?
Half and a fifth.
Well, if you're doing this, you'd probably say it's not very easy to add these, but what if we cut every slice here in half? How many slices is that pizza now? 10. And how many slices do I have of it? 2 of the 10. And what if I cut each of these halves into 5? Perfectly even. You know what? I'm doing my best. Doing my best. Best I can do. Shh. This is harder than it should be, which I think says something about my mental acuity, but that's okay. Now, if I cut this into 10, how many of those slices do I have? 5. And all together, what do I have? 7/10. Does that make sense? Right? Oh.
Kinda.
So what do you have to find? You have to, not a common factor, but a common denominator. You have to make the denominators common. You have to find a common denominator. And the easiest thing to do, when in doubt, if you don't know what to do, what can you always do? You can take this denominator and multiply it by that denominator, and that can be your common denominator, right? What's 5 times 2? 10. Okay, and to get this to equal 10, what could I multiply this by? 2. What would I have to multiply the top by? 2, which would give me 2 over 10. And then if I want this to be 10, I'd have to multiply it by 5, which means I'd have to multiply this by, which would give me 5/10, right? And then when I add those together, I would get 7/10. All right? So when in doubt, now, will that always give you the lowest common denominator? No, but it'll at least always give you a common denominator. So when in doubt, multiply this whole fraction by whatever this denominator is, and multiply this whole fraction by whatever that denominator is. Now, sometimes you're not going to want to do that. For example, you don't have to write this, but you could. What if we had 1/3 plus 1/6? Could I, if I wanted to, multiply this by 6 on the top and the bottom and multiply this by 3 on the top and the bottom? Would that work? Yeah, but is there an easier way to get a common denominator here? Which is what? I could leave this one alone, and what could I do with this one? Just multiply it by 2. So if you can eyeball a better way, do it a better way. Does that make sense? If you can eyeball a better way, do it a better way. In this case, 2 times 1 is 2. 2 times 3 is, so that's 1/3 is the same as saying 2/6, and then plus 1/6. And what's that equal? 3 over 6. And is there a better way to say 3/6? 1/2. Okay. Fractions. It's the grade 6 math that tends to haunt us. Hands up if you're a little haunted by this grade 6 math. Yeah, practice is what I can tell you. You got to be a little bit fluent with fractions. But do we at least, even if we're not super fluid with it, do we understand the idea there? Yeah? Okay. Because it's going to come up today. And this thing where we just multiply by the other one is usually a pretty good trick. But of course here, we're going to be working with slightly trickier stuff. Okay, now this is pretty similar, right? What are we going to meet with as a common denominator here? For 2 and 5, we're going to say the common denominator is 10, which means I have to multiply this one by what?
2.
2, which gives me what?
Shh.
Write it down. So, rhetorical, what does it give me? Everyone write it down. If I multiply top and bottom of this by 2, what do I get? 3, 2, 1, what do I get?
2 over 10.
2 over?
10x.
10x. Good. Everyone comfortable with that? Okay. And then we're adding. I'm going to do that so we know where it came from. What do I have to do with this one to get to 10? Yeah. And I should say our common denominator isn't actually 10. Our common denominator is 10x. And I should have mentioned that. So we multiply the bottom by 5. And if we multiply the bottom by 5, to keep it the same fraction, we have to multiply the top by 5. And what will that give me?
10 over 10x.
10 over 10x. Okay? How's that feel? Okay? Not too bad? Okay. And when we do that math, what do we get now? Oh, I know. I get 12 over 20x, right?
No.
Why isn't that right? Because if you have half a pizza and I have half a pizza, together we haven't had 2/4 of a pizza, right? Together we've had 2 halves of a pizza or a whole pizza. When you know what fractions are, you know that when you're adding, you don't change the denominator, you change the numerator, right? And is that the best way to write that fraction? Can top and bottom both be divided by something here? We can divide this by 2, which means we can divide this also by 2, yielding what? 6 over 5x. And there's our solution. Good. How did that feel? A little rough? Not too bad? Just bad enough? Okay. Usually that's a little rough for people just because we don't do fractions all that often. We tend to find them intimidating, right? And find fractions a little intimidating. I'd like you to take 30 seconds and address the people that you share a table with or possibly next to you and say what you find scariest about fractions, or what you like
the next
least about them.
question.
But then, I think this is important in life, you also have to say what you like most about fractions. You have 1 minute. Go. What do you like about fractions? Everything like everything. Fractions are your best friends forever. It's not a fraction fact, but would anyone like to share with the class something they learned about one of their friends, fraction related? Good or bad? Yes, ma'am. See what? Sure, because they get confusing, right? Yeah, I agree. Yeah. Sure. I like it. It sounds like maybe you didn't report exactly what she said, but that's okay. How'd she do? How'd she do reporting what you said?
It was okay. I give it like a 7 out of 10.
That's pretty good. That's pretty good. That's better than most of my university marks. Not most of, that's not true, but a solid chunk of. Anyway. All right. Now you try one. You got 2.5 minutes. Get this one done.
Only 2.5. I'm gonna spend triple that trying to figure out what I'm looking at.
What is the common denominator? Maybe we'll do that part together. What's the common denominator going to be?
6.
Okay, well, the number part of it is obvious, right? Which is just 6. And then what about x's? This one has 2. How many does this have? 1. So what's going to be easier, to divide by x here or to just give another one here?
Give another one.
Okay, so the common denominator will be 6 and then x squared and then what else? Y. Is there any reason to do x cubed? You could do it. Does it help you any? No, so I wouldn't bother. So that's going to be your common denominator, 6x squared y. What do you have to multiply this by to make it 6x squared y? What do you have to multiply that by to make it 6x squared y? You got this. Yep, you can do that. You're going to end up with an extra x that you're going to deal with later. It's fine. You'll get the right answer. Nothing wrong with it. Does that make sense? It's not the most parsimonious solution. Like, it's not the simplest solution to get you there, but it's a good solution. So find it. And that's the thing you're going to find in math. There's a million ways to do questions. So just because I show one up here doesn't mean it's the only way. And I love when people find it. You can go your own way. You can call it another lonely day.
I'm struggling.
Another
I can
lonely
get the
day.
numbers, I just can't get the I'm gonna get like a 24 package, like
2 times 2. Plus x times 3.
Guys, is Evan out there?
Yes.
Great. Sarah's out there, right?
Yes.
Alexander's though, right?
Yeah.
Samuel's back there, right?
Yeah. Give me a moment before I cry. Oh, he asked me. I saw you that once. Not you. I saw you guys walking. I was literally behind you. Walking behind you. Like, no, until you like turned.
What the hell?
Yeah.
Oh, wait.
Guys, there's a lot of talk. It better be a lot of talk from people who have this answer down.
Hold on, Mr. Orlando, I got a question.
Yeah.
When you do x times 3, would it be 3x or x cubed?
If you were to multiply this by 3x,
No. The top one. The top one on the right. It's just x.
yep. So what are you multiplying it by?
3.
Then it'd be 3x.
3x, got it.
Yeah, if that's all you multiply it by. All right. Shh. Look here. So here's the simple rule we're going to say. Shh. You're never going to make a denominator have less stuff in it. Does that make sense? We're always going to multiply more stuff to the denominator. So like this has a 3, that has a 2. You're never going to make it go lower than that. You're going to make it go higher. Maybe you'll leave it alone, but can we leave 3 and 2 alone? We said no, it has to go to 6. This has x squared. This just has x. So we can't make this x squared go lower. We're going to have to make this one turn into x squared, right? And then this one has a y, this one doesn't. So you know what we're going to have to put over here? A y. You can only put more things into the denominator. I mean, you can mathematically get things out of the denominator, but it's messy and it's just not how we're going to approach it. Because do we like dividing when we're already a fraction? No. Okay, so we need to take 3x squared and turn it into 6x squared y. So what do we need to do? How do we get the 3 to turn into a 6? We need to multiply it by 2. And then we need to get the x squared and turn it into x squared y. So we also need to multiply it by y.
Oh, I didn't know.
So in the end, we're multiplying it by 2y. What do I have to multiply the top by then? 2y. Okay, let's do that. What's that going to give us? What's 2y times 2y? You could say 2y squared. Nothing wrong with that. It's not the easiest thing, but it's perfectly valid. What's 2 times 2? 4. What's y times y? Y squared. But if you have 2y squared, as long as it's in brackets, that's cool. Nothing wrong with that.
I had 4y.
One sec. Sorry? You could put this all in brackets, but then the brackets would go on the outside. Listen, this is saying take everything here and square it, which would mean take the 2 and square it, which gives you 2 times 2 is 4. And what's y squared? Just y squared. By the way, if you wanted to, you could do a middle step where you wrote it like this if you really wanted. That'd be kind of clumsy. But like you could have 2 squared y squared. Now, is that helpful? I hate that. I hate that with a passion. But it's not mathematically wrong. But do you see why we don't really want to do that? And even this isn't wrong, but it's a little bit clumsy, right? This is a lot easier to read for the most part. Though if you had an ugly number here, like a 36, you might want to leave it in brackets and squared, so you didn't have to write down what 36 squared is. So it kind of depends on what's useful. Does that make sense? Cool. Okay, and then the bottom, well, we know what the bottom is going to be. 2 times 3 is 6. X squared with no other x's will just be x squared. And y with nothing to change it will be y. But of course we knew that because we're intentionally making the denominator 6x squared y, right? Okay, now we're going to add. Now, what has to change here? We need to turn the 2 into a 6. What are we going to have to multiply by?
3.
Then we need to turn the x into an x squared. What are we going to have to multiply by? X.
No.
Not x squared, because we already have 1. We just need 1 more. And then we have a y, and we want it to be a y. Do we need to multiply by anything?
No.
No. So 3 will turn the 2 into a 6. X will turn the x into x squared. And we don't need anything to make the y be a y. If we multiplied the bottom by 3x, what do we multiply the top by? 3x. Awesome. What's this going to be over here? What's x times 3x?
3x squared.
3x squared. And here only the x is squared, right? The 3 hasn't changed at all. 3 with nothing to change it is 3. X times x is x squared. And what's on the bottom? Well, 2 times 3 is 6. X times x is
X squared.
x squared. And y with nothing to change it is just
Y.
y. But of course, we knew it was going to be 6x squared y because we did that on purpose, right? That's what we were trying to get. And now, what's the top of this thing? Can we add those? Are they like terms? No. So it's not pretty. We just say 4y squared plus 3x squared. But at least now, because they're a common denominator, we can write it over the same denominator, which is 6x squared y. And then I can cancel that x squared with that x squared. And that 3 cancels with that 6 and gives me a 2, right? And that y will cancel with one of those, right?
Wait.
Can I do all that?
Slow down.
It's addition. I can't do any of that. Is there anything I can cancel? Nothing. Does that make sense? Nothing I can cancel. Well, God, you blind me, follow me. If I was like, and now we can jump off the roof, would you just be like, okay, I guess I'm jumping off the roof. Orlando did it. And that guy, has great hair and he's so tough and he's devilishly handsome. And he's so good at math.
Did a blind guy say that? Sorry, I'm kidding. Your hair's awesome.
Kartik, I would say I need glasses, but I wouldn't call myself blind. Anyway. Kodik, you cut me to the quick, sir. Kodik, the same blind guy who said that's going to be the guy who enters all your grades. You should just keep that in mind.
Where's that FT again?
You know, an 8 and a 2 look so similar when you're blind, Kodik. All right, so anyway, where was I? Other than threatening Kodik to change his grades because he insulted my looks. Listen, if every time somebody insulted my looks, I changed their grades. It would be just like now because that's what I do every time. Just so you know. Angela, that's recently what I said to your grade book entry. So let's get back to it. All right. So now we're going to get tricky because what do we have here? Oh, we got factors, baby.
Oh, no.
We got factors. Get excited. Who's excited? What? Are you excited?
No.
I'm excited. Okay, so listen. Hi, what can I do for you? Can you do what? Yeah, they're over there. You're going to make sure it comes back to me by the end of the period, my friend? Thank you very much. All right, so listen. What's our common denominator here? Common denominator. Whoa. Do we want to start dealing? Here's the good news. Make it easy. I said when in doubt, take the denominator from this one and multiply it by the denominator from that one, and that is your common denominator. So for our common denominator, we're going to keep it easy. It's going to be x minus 3 times x plus 2. Does that make sense? That's it. That's all we're going to do. We're just going to say take the one denominator, take the other denominator, and we know that they'll be common if our common denominator is just those two things multiplied by each other. Does that make sense? Right? That's no difference than when we had a third plus a fifth saying when in doubt, our common denominator could be 3 times 5, which is 15, right? And then you'd multiply this one by 5 on the top and bottom, and multiply this one by 3 on the top and bottom, right? This is no different than that. It's uglier than that, but it's no different. Our common denominator, and we're not going to expand it. Maybe at the end we'll expand it, but not yet, because we might get lucky and we might get to cancel something. And if we get to do some canceling, that makes our lives easy. So are we going to do any, we're not going to multiply this out. We're just going to make that our common denominator, which means, what do I need to multiply this one by? x plus 2. And if I do it to the bottom of a fraction, I need to do it to the top. Cool. What about over here? What do I need to multiply top and bottom by? X minus 3, yep. Sorry about that. And x minus 3. All right. Let's do it. You excited?
No.
That makes this first fraction on the bottom, we have x plus 2, x minus 3. And the second fraction on the bottom, we have x plus 2, x minus 3. That's not so bad, is it? And then, what do we have up here? Okay, x plus 2 times x plus 5. And then what do we have over here? x minus 7 times x minus 3. Good. Now, I know you could cancel, but do we want to cancel here? The whole point of this is to get these into a single fraction, right? So now, do we need to have two fractions? No, because what's the denominator of the whole thing? X plus 2 times x minus 3. But now what do we have on the top and bottom? Well, it's going to be long, isn't it? So we have x plus 2 times x plus 5. And then we're adding, bless you, for a cough, I guess you can still be blessed. I bless you. Over here, x minus 7 times x minus 3. Now, here's the problem, team. Can we simplify that? Yeah, but what are we going to have to do? No. We're going to have to multiply this out, right? And we're going to have to multiply this out. But listen, you know the rules. Listen, here's what we're not going to do. We're not going to start drawing arrows because we know our multiplication rules. All right? When you multiply binomials, what do? How many terms are we going to get? We're going to get an x squared term, and we're going to get an x term, and we're going to get a term with no numbers, right? We know that? With this one, will there be an a value?
Yeah, wait, no.
How do we know?
Because it's just x.
Yeah, there's no number on the x. So will there be a number on this x?
No.
No, it can't be, right? X times x is just x squared. Okay, now, guys, you know how to get the middle number and the end number. How do these two numbers give you the middle number? You add them. So how many x's will there be? 7x. And how do you get the final number? What do you do with those two numbers? You multiply them, 10. Do you see why that becomes such an important skill to be able to do that quickly? Do you want to be collecting like terms and doing all kinds of messy math on the top of this thing? I'll tell you who doesn't. This guy. All right. Now let's pause. Do the same for this other side. Do the same for over here. Write down what you get. Don't shout it out. And I want you to do it in 15 seconds, or then we'll do it together. Same rules. Oh, good question. I wouldn't. Because there won't be any like terms to collect, right? This is only one binomial. The reason we're expanding the top is because we have two binomials, and we can turn that into a single one. Right? We can actually collect all the like terms here. There'll be nothing to collect on the bottom, so it'd be a waste of time. Sam?
Probably already mentioned this, but we have like the x plus 2 and x minus 2 twice.
That's right. And the reason is because these are a common denominator. So just like a third plus 5/3, what's that equal? Well, it equals 1 plus 5/3, which equals 6/3. Does that make sense? If they're common denominators, you can write it as a single fraction. If they're both divided by 3, then we can write it as just the whole thing divided by 3. Do you know that rule? Like, do you see that that and that are really saying the same thing? Okay, but very good. I'm glad you mentioned it. Did everyone else catch that I did that? I'm not going to keep writing these out with the denominator written twice, because as soon as they have a common denominator, I can write them as a single fraction. Very good question. Glad you noticed it. Hopefully you noticed it too. All right, what do we get from this? What's the first term?
X squared.
X squared. Quiet. Next one. How much? Negative 10x. Beautiful. And the final one? Plus 21. Cool. All right. That's okay. If you make a mistake, you make a mistake. Can we collect like terms here?
Yes.
What do we get?
2x squared.
2x squared
Minus 3x.
minus 3x
Plus 31.
plus 31. Now,
Where'd you get the 2 from for the
x squared plus x squared is
Oh, X.
2x squared. Plus 7x minus 10x is minus 3x. Plus 10 plus 21 is plus 31. And then down here we still have x plus 2, x minus 3. Now, we should check to see if the top factors. It might not. Can we divide anything out? Like a 2? No, nothing nice, right? AC rule tells us we'd need two numbers that multiply to 62. I can't, what do we got? I don't know. That'd be 31 and 2, right? Anything else? I don't think so. I don't know my 62 times tables very well, but nothing, right? 31's prime number, right? So, will this factor? No? So we can leave it alone. Now, if we want to, could we also expand the bottom? If we want to. And is it actually hard?
No.
No. So it's just your preference, whatever you like. That's a good answer. Or if we like, we could say 2x squared minus 3x plus 31. And what would the expansion on the bottom be? One sec. What's the first term going to be?
X squared.
Yeah, slow. Not you now. Second term would be? Yep. Sorry? Minus x, minus 1x if you like. And the last term would be 2 and negative 3. The last term would be beautiful. Very good. These are both right answers. I don't care which one you prefer.
Yeah, I'm going to do that because it just looks fun.
I kind of like the look of if the bottom's in expanded form, I like them to be the same, but it doesn't really matter. And if the top had factored, I probably would have done them both in factored form. You know what I mean? Not a terrible thing to note. This doesn't factor. We don't need to state restrictions because we never canceled anything on the bottom, but we still could state restrictions if we wanted to. Is there anything that x can't equal here? X can't equal, I think it can equal positive 6. Because if it was, it'd be 6 squared is 36, minus 6 is 30, minus 6 more is 24. So that's allowed. What couldn't it equal? X can equal 0. That'd be 0 squared, which is 0, minus 0, which is still 0, minus 6, which is negative 6. So that's allowed. X can't equal negative 2, and x can't equal positive 3.
How did we get this, guys?
Because what can't you divide by? What can't you divide by? 0.
I said 0 was restricted.
But x can be 0. What can't be 0 is x plus 2 times x minus 3. So that means that x plus 2 can't be 0, right? Which means x can't be negative 2. And it means that x minus 3 can't be 0, which means that x can't be 3. Now again, why don't we have to state them here? And where sometimes, A, the question didn't ask us to, but B, why don't we need to state them? Because they're still down there. You know what I mean? So it's only when we cancel something that we need to explicitly make sure we state it as a restriction, because we've gotten rid of the restriction, but we need to still say, hey, by the way, even though I canceled it, x can't equal negative 2. Here I didn't cancel it, so you don't have to say it, but can I give you advice? Never hurts to state restrictions. You'll never go wrong stating them. Does that make sense? So when in doubt, tell me what your restrictions are. Any questions about that? That's a tricky little question, yeah?
Wait, can I just double check? So, like, you can't have negative 2 and positive 3 because if you put the negative 3 and positive 3 together, it's 0, right?
If you put either one in. You can't put them both in because x can't equal two different things at the same time.
Okay.
But if we put negative 2 in, this would be negative 2 plus 2, which is 0, times negative 2 minus 3, which is negative 5, but 0 times negative 5 is 0, and you'd be dividing by 0. So you can't put negative 2 in. You can't put positive 3 in, because then it'd be 3 plus 2, which is 5, times 3 minus 3, which is 0, and 5 times 0 is 0, and you can't divide by 0. So any value of x that makes the bottom of a fraction equal 0 is a restriction. Did that answer your question? Like, usefully?
Like, that clarified all my questions.
Amazing. Hey, even a broken clock, twice a day. Am I right?
I heard you say that like 100 times.
That's because it's been true 100 times. Okay, this one here, what's going to be the easiest way to figure out our common denominator? What should we do first, which will make figuring out a common denominator a lot easier? Sam, what do you think? What makes this really ugly right now in terms of denominators? All this jazz, right? Is there any way to multiply this by something and get to look like that? I mean, there probably is, but is it easy to know what you could do? Not for me, at least. So what would be an easy thing to do with this? When in doubt, When in doubt, factor, baby. That's right. So let's factor that. Let's rewrite this line. What's the top of this fraction still, obviously? So we'll say x plus 2. And the second one is 1 over x minus 5. And we're going to factor this bottom one. All right, we can do that. We need two numbers that multiply to 2. What are the options? 2 and 1. Or -2 and -1. Obviously, which one do we like?
2 and 1.
2 and 1. So what's this factor to?
X plus. Well, I'm gonna write x plus 1 and x plus 2.
X plus 1 and
X plus 2.
okay. Now we got lucky. What has happened here? We can cancel it. Is that going to make our math a lot easier?
Yes.
Oh yeah, you're right. It is. Now, if we forgot to cancel it now, could we still do the question? Would everything work? Yeah. Is it going to be way uglier? You betcha. So you know what we're going to do? If it lets us cancel here, let's cancel. Which means what do we have now? What's on the top here now?
1. Yeah.
Give me my straight line. 1 over what? Okay, and then what do we have over here? Okay, what's our common denominator going to be? So I'm just going to write a note up here that we factored to make finding the common denominator easier. And then what is the common denominator here? We said when in doubt, do what with the two denominators?
Multiply them.
Multiply them together. So the common denominator will just be x plus 1 times
minus 5.
x minus 5. Should I expand that?
No.
Absolutely not. Does that make sense? When in doubt, just make your common denominator both of these put together. By the way, if we'd had to do it here, what would our common denominator have to be? It would have to be x plus 1 times x plus 2 times x minus 5. Can we see how that would be uglier and more of a pain in the butt?
Yeah.
So it's nice that we spotted that we could cancel that so that it makes our lives easier. So now, what am I going to have to multiply this fraction by, top and bottom?
X minus 5.
X minus 5, because we don't have that one. Does that make sense? What am I going to have to multiply this one by, top and bottom?
X plus 1.
X plus 1. Does that make sense? A little weird, right? Anyone find that a little weird?
Yeah.
That's okay. Let's give it a try. So now, whoops. What will the denominator be down here now? X minus 5 times x plus 1. And what about over here? X minus 5 times x plus 1. By the way, does it matter that I've switched the order from what I said it was up here? Multiplication, does it depend on order?
No.
Is 3 times 2 different than 2 times 3?
No.
Nah, so you're good. All right, what's going to be on the top here? X minus 5. And on the top here? X plus 1. Great. And if we have two fractions, we can combine them into a single fraction as long as the denominators are the denominators the same?
Yeah.
Great. Since we have that common denominator, we can do this. And now what would be on the top? X minus 5 plus
X plus 1.
plus x plus 1. What will we get from that? 2x minus 4. And on the bottom, still x minus 5, x plus 1. And that is a good answer. Usually in math, if we're able to, we will do what with a final answer? And there's one little piece of simplifying we can do here, which isn't necessary, but would usually be considered good manners. What do we notice about the top of this fraction? It can be factored. What can it be divided by? Sorry? Nope, I can't take an x out of the top. What are they both divisible by, though? Both divisible by 2. So good math manners would usually insist that we factor the 2 out. 2x, if we factor the 2 out, would be? Great. And -4, if we factored 2 of that out, would be -2. So that would usually be considered better, but these are both good answers. Kartik, your hand shot up as if I had just announced that the first person who puts their hand up will get free Taylor Swift tickets. So I'm assuming you have something very exciting to add. Yes?
How did we go from, like, plus x plus 1 to 2x minus 4. Because wouldn't
What's
that-
x plus x? Collect
No,
like
but
terms.
Wouldn't they be in brackets though? Like,
Are the brackets doing anything? What's the purpose of a bracket? It says you have to do the math inside of them, right? But can you do x minus 5? Like, okay, so put brackets around these. But what's the bracket telling you to do? Well, here it's telling you to divide by those, right? But are we going to divide by them first? Well, no, now that we're dividing them all by the same thing. In other words, if brackets aren't doing anything, you know what you can do with them? Erase them, right? So the bracket around that wouldn't be doing anything. So yeah, just erase it. That's a good question, by the way. It's a very good question. But yeah, if your brackets aren't actually causing you to do some math before other math, then you don't need them, and you can just erase them. No, you're welcome. That was a great question. A very good question. Any other very good questions about that? How's this feel? You want to know a weird thing? People tend to do better with this than they do with adding and subtracting just normal fractions with just numbers. And I don't for the life of me know why you guys do better with adding and subtracting weirdo fractions like this than you do with just like a fifth plus 2/3. But you do. And I think it speaks to the fact that like people like a challenge. And so when something is tricky, they like buy in and do well with it. Whereas when something's just a little bit tricky, they maybe just get frustrated with it and say, screw this. Okay, we're almost done. Subtracting. Subtracting follows the same rules. We won't get through all these, but that's okay. You can still do the homework because we'll get through enough of these. What's the common denominator here?
X minus 6 times x plus 6.
X minus 6 times x plus 6. Okay. Which means what will we have to do with this first fraction? Multiply it by x plus 6 times x plus 6, right? And what will we have to do with this one? And, okay. Now, we can do this. This will be x plus 6 times x minus 6 for the first fraction. And then we're going to subtract, and the second fraction will be x plus 6. Oh. Now, are we going to stop very quickly writing this fraction twice? In fact, are you guys comfortable if I don't write it twice now? Okay, you sure? Okay. Now, keep in mind, we do have to be careful still, because what we want to make sure we do is this. What will this first fraction end up being? This will just be x plus 6. I'm going to read, yeah. So that'll be x plus 6, right? And then what are we doing between them? Subtracting. And here we do want a bracket. So I'm glad Kartik mentioned that last time because it's going to be important. What goes in the bracket here? What will that be?
For the first one as well.
X minus 6, right? Now, why did I want to put that bracket there? Because that negative sign is going to apply not just to the first thing, but to the second one as well. Which means we should write this as x plus 6, x minus 6. Okay, x plus 6, and then what will this be? Minus x, and what will this be?
Plus 6.
Yeah, negative 6 is the same as saying add 6. Subtracting a negative is the same as adding. And now, trivial, you can collect like terms. So we have x plus 6, x minus 6, and what are our like terms here? Does x have a like term? What is it? Okay, and what's that? Nothing. And does 6 have a like term? The other 6, which gives us 12. So what's left on top here? 12. So the answer is 12 over x plus 6, x minus 6.
Wait.
You could. Could we expand the bottom if we wanted to?
Why did you multiply? Wait, no, you added. Never mind. Oh, wait, you're collecting like. Okay.
Just collect. If we wanted to expand that, it's real easy. What's the leading term? X squared. How many x's do we get in the middle one? What do we do with those two numbers? Add them, which in this case will be what? 0. So do I need to write 0x? No, so we'll just do that. And what's the last term? Negative 36. And what's still on the top? 12. Those are both good answers. I don't like one more than the other.
Amigos, on today's cafeteria menu, we have minestrone soup for $2, salad for $4,
Great.
buttered chicken and rice for $4.
I like this
and
better.
meat lasagna for $6 with breadsticks. That's all on today's cafeteria menu. Have yourselves a great day, Eagles.
This would be considered more simplified, by the way. Usually, when we say simplify something, we actually like the factored version of it. So when in doubt, expand and then factor. But factored form is nicer. I'm not done. Yeah. So listen, we might not get this one finished, but we can sure start it. If I want to find a common denominator here, what am I going to have to do first?
Factor.
I'm going to have to factor, right? Remember when I said factoring wasn't going to go away? I wasn't kidding, was I? You know what has not gone away? Factoring. Okay. This bottom one here, we need two numbers that multiply to what?
Negative 40.
Negative 4.
I got negative 48.
Does yours have an 8? What is going on with this stupid thing? Okay. They need to multiply to negative 48. And they need to add to positive 2. Is that actually a 2? Dear God. So what are the possibilities? Obviously negative 48 and 1, but that's not helping us, right? Negative 1 and 48. Negative 12 and positive 4. What else? I know one. Negative 6 times positive 8. Do we see that? 6 times 8 is 48. So what are my numbers here? X minus 6 and x plus 8. Cool. What about down here? I need two numbers that multiply to what? Negative 30, but they have to add to 1. Thank you very much. So what could that be? Negative 6 times positive 5. Yeah, by the way, it could have been negative 30 times 1. Could have been negative 15 times 2. But the one we're looking for is negative 6 times. Obviously, could have also been negative 3 times 10, right? But yeah, we want negative 6 and 5. So what goes in the brackets here? X plus 5. Okay, what's our common denominator going to be? It's going to be miserable. It's going to be x minus 6 and x plus 8 and x plus 5. There's 3. Is that allowed? Yeah, are we going to expand that? Nope. All right, we'll finish this one tomorrow. We'll go from there. Tomorrow we're going to finish this, then we're just going to do some practice. You are going to have a little quiz tomorrow. All right, quiz tomorrow. Can somebody write that on the board under our math one? You can erase what's there too. A little quiz tomorrow. It's not going to cover today's lesson, but it'll go up to yesterday's lesson, or to Monday's lesson. Yes, sir. There you go. You guys are doing a great job with this. Don't be shy if you need help with it. Please come in. But listen, the nice thing is, this tends to be where the factoring bullet meets the bone. Like you'll start to get real good at it because you're going to do a lot of it. What's canceled? By the way, let me start on the word mentee. That's not a word. I mean, it is a word, I guess. You use something, it becomes a word, but it's not a good word. About? See? I know what I speak.
Oh, and you don't listen to me?
Would you listen to you? Have you met you?
That's a real time of 30.
I will bug you for details later, but
No,
I said later.
no, it's a shorter Let's go.
I stood there like 5 seconds. I'm like waiting, and nothing's happening.
That must be very hard for you.
I know it is.
Do you ever play the looping pedal? You ever use the looper?
No. I play acoustic Mr. Orlando.
Neil doesn't have one?
Huh?
Turns out I have no idea how to play it. The looper is great because you can record yourself and then play along, which it turns out very helpful. This is like when I'm playing live, I don't loop very much because I mostly play with a partner and I'm not great with them. I'm not into like looping big drum parts or anything like that. But what I will often do is actually loop my vocal if I'm playing solo. So I'll record the chorus the first time I'm playing through with my foot pedal, and then the second time through I'll play the chorus and I can sing the harmony part. So at least like the second chorus has like the melody and the harmony. Or what I'll do is I'll record a verse while I'm playing, and then when I'm ready I can press play on that, and I can I can solo over top of it, right? So give myself a little bit of lead, right? So if I'm playing. Let's go with a slightly more useful.
This looks really complicated.
You know what? It's not nearly as complicated as it looks. Oh, did I actually save that with everything turned on? That was a mistake. So like what you could do is just when you're playing something, you would like to. So just while you're playing a song, you can.
No, your shoes are dirty.
And so on and so forth. So, but then you can also, and I'm not very good at this, like the smarter people who have, what's that thing, talent, will build like a big, get real symphonic with it, right? Why won't this guitar stand too? And the strings are old. But oh my god. Jeez Louise. Come on.
Use my electric. So I can try
What?
to on this. You know, there's a
Scratching them
gap
out.
here.
Yeah.
I can actually.
I've never seen anyone do that in my life. That's kind of scary.
When you put new strings on, it's the thing to do. Just like stretch the heck out of them.
You know, honestly, sure.
And because otherwise it takes days for them to get stretched out.
I really don't care.
It's my bag for a long time.
Like,
Okay, that's fair enough. We'll eat it.
so yeah, so you could go like,
Launch right now.
and I'm again,
Alright.
just pick a,
Never mind. Make sure you want to
I'll take like a piece. Not a bite.
This is music my uncle made.
the taste like.
He made music.
Like a history book. Tastes like a really old book.
Is it really
Like
old?
no apples.
Is it like bad?
Not really. It's more awful.
bought them for all the coaches last year, but I'm thinking, how would you feel about we all pay a little bit of money and we just have our own jerseys this year?
Yeah.
Like just, I think you could wear this as a jersey. Check with rules.
As long as there's a number.
I think as long as there's a number on it,
Oh.
and then you can keep them. Cost a bit of money. How do we feel about that?
I love that.
And like, I think if there's a couple people it's an issue for, we could obviously help. Can I hear?
Just the
Yeah, I'm gonna leave or more. Yeah, but you know what's going on. I've been wanting more to